Okay, so now we are going to we're going to look at some problems where we apply Newton's law. So Newton's laws, they are basically F and the net force that is equal to mass times acceleration. That is your basic Newton law. And these have two components. It has a x component and a y component. So that is equal to mass times the acceleration in the x-axis, and this is equal to mass times the acceleration in the y-axis. A typical set of problems that we're going to encounter occur when the acceleration is equal to 0, ax equal to 0, ay equal to 0. In this case, the object is at rest, not moving, or moving at constant velocity. So those are the two type of problems that we're going to deal with first. So constant velocity and at rest. So if that is the case, then Newton's law, they reduce to these two expressions here, and we need to apply these two expressions to solve problems. So how do we do that? Well, remember there is a recipe. You prepare, you solve, and you assess. So to prepare, you make sure you identified all the forces, make sure the object is either at rest or moving at constant velocity, therefore the acceleration is equal to 0. Identified all the forces and then draw a free body diagram. Very important. You draw a free body diagram, then from the free body diagram you write Newton's equations, and then from there you can solve for the forces or for whatever value you need to find. So let's look at a quick example of how to do that. So we have here a car. So the car is being pulled, right? So by this rope. And so the car is moving. So you have a car with a mass of 1500 kilograms and it's being towed at a steady speed. So the velocity is constant. So the acceleration is 0. So we know that. So we are given this angle of 20 degrees. And the friction force, there is a friction force between the tires and the rope, and that is 320 newtons, we are told. So, and it opposes, of course, friction opposes the motion, so the friction force opposes the motion here. So the question is, what is the tension on this rope? So when you work on this problem, so the first step is to prepare. So a picture here would be helpful. So here we already have one, and then we circle the car, which is the object of interest, and then we identify the forces. We have a friction force, we have the weight of the car, we have the normal force, and we have the tension. So it is also useful to list things that we know. We know the angle, the mass, the friction force, and when we need to find the tension. So now let's draw a free body diagram. So start with X and Y. So this is the car, so this is X, this is Y, and then let's draw the forces. So well, we have the weight, W, we have the normal force, right, that adds up, and then we have the tension, T, and this angle is theta, which is 20 degrees. And finally, we have the friction force that opposes the motion, and that is F. So we have all the forces, so now we need to write Newton's equations, so let's do that. So to write Newton's equations, we start with the x-axis, and we write the x component of the tension minus the friction force, that is equal to 0. And then we do the same for the y-axis. We write that the normal force plus the y component of the tension minus the weight, that is equal to 0. Of course, this is equal to mass times the acceleration in x, and this is equal to mass times the acceleration in y, but both are 0 because it's moving at constant velocity. So the question was to find the tension, so maybe we can use the first equation to find the tension. Tx from the trigonometry here, you can see that is T cosine theta, right? Tx is t cosine theta, so we can rewrite this equation as t cosine theta minus the friction, that is equal to 0, and then we can write that t is equal to the friction divided by the cosine of theta. And then we can do the math here. We can write that 320 divided by the cosine of 20 degrees, right? So 320 divided by the cosine of 20 degrees, that is equal to 340 newtons. So that is your force, the force acting on a body. So that is how you solve this type of problems. Here is a better free body diagram. By that I mean neater. So, and then you do the math, and then you get 340 newtons, which is your solution. So that is all that basically there is to equilibrium. So you just write Newton's equations and then you solve for whatever you need to solve.